Okay, today we are going to look at rational exponents. Remember, rational simply means fraction. So we're going to be dealing with exponents that are fractions. So we need to know how to interpret those. So if you were given a expression that has a fraction exponent, so in this case our base is x, so this is our base, then we have this fraction exponent here. So what we need to do is know what those things stand for. So the top part of this fraction, the numerator, is going to stand for the normal exponent. So that's going to become a normal old exponent, not in a fraction anymore. This bottom number of the fraction is going to be the index of the radical. And we talked about this in our last lesson, that the index is the number in the little root here that tells you what kind of root it is. If there's nothing there, it's a square root, which tells me that if this was a 2, then this would be a 2, but I generally don't write that, so I would just have the radical with nothing in there. However, if it's anything else, like if this is 3, then that means you have a cube root. If it's 4, that means you have a fourth root, and so forth and so on. Now, there are two ways that you can write these. You can take that base to the normal exponent and then put all of that inside the radical with the index, or you can take that base, put it inside the radical, and then that whole thing is raised to that normal exponent from the top of the fraction. Either one is going to get you to the same answer, but sometimes one way is a little bit easier than the other. So what we need to remember is the top number is the exponent, the bottom number is the index for the radical. We've got to be able to remember that. The base always stays the same, but the top number is the normal exponent, the bottom number is the index of the radical. So let's take a look at a few problems and we can practice this and kind of see how it's going to work. All right, so one of the first things that I always do is look at what kind of radical am I going to have. So on the bottom I have a 2. That means it's going to be a square root. So I'm going to have a plain old square root, which means I don't have to have anything written here for my index. I don't need a 2 there. If you want to put it there to make yourself feel better, that's fine, but it's not needed. We know that if there's nothing there, it's a square root. We know that our base is going to go inside of that. So we've done everything except for this 1. Well, that 1's going to be an exponent. So I have two ways that I can do it. I can raise that base to the first power and then take the square root, or I can take the square root and then raise that whole thing to the first power. Either way, it's going to be the same. So basically, if this is a 1, it's not going to change anything, because if you have an exponent of 1, nothing happens. It's just a single thing. If it's squared, there's 2 of those things multiplied together. But if it's just 1, then there's just one thing. So if you have a 1, then really it's not going to serve a purpose. It's technically there, but it doesn't actually do anything. So really, this is just the square root of 144, which, since that's a perfect square, we know is 12. All right, so that's the first one. Let's take a look at this second one. So it's very similar. We have that 1 on top, which we know is the exponent, but an exponent of 1 isn't really going to do anything. But this time we have a 3 on the bottom, which means that I no longer have a square root, I now have a cube root. So I need to know what is the cube root of 512. And so if we think back to our perfect squares and perfect cubes that we talked about in 7.1, we know that the cube root of 512 is going to simply be 8, because 8 cubed equals 512. Therefore, the cube root of 512 equals 8. All right, now for number 3, we need to be really careful about this. So it says 4m to the 1/3 power. And this is a really common mistake. We need to understand that this means 4 times m to the 1/3 power. That 4 is not being raised to the 1/3 power. So we know that this tells us we're going to have a cube root, but that cube root is only going to be over the m. it's not going to be over the 4 as well. So what we're going to have then is we're going to have 4 times, instead of m to the 1/3 power, we're going to write that as the cube root of m. And since this is technically to the first power, well, m to the first power is still just m, which means that doesn't really do anything. It's not needed. Then since I don't know what m is, I can't take the cube root of m. I don't have m to the 3rd, so I can't break that down. I'm just going to have to leave it like that. That's really all I can do. It can't be simplified. The big thing is understanding that this is not inside of the radical given to us by that number. All right, let's take a look at some more. All right, for number 4, we have 36x to the 4th inside of parentheses and being raised to the 1/2 power. Now, because all of this is in parentheses, that tells me that all of it is going to be inside the radical. And what kind of radical is it going to be? A square root. So we have the square root of, and then we have 36x to the 4th, and then technically that's raised to the 1st power, but again, it's not really going to do anything, so I'm not even going to bother with it. It's technically there, but it just doesn't do anything. So if that's really just the square root of 36x to the 4th, well, then that becomes just like the problems that we did in 7.1. We know that the square root of 36 is 6, and we know the square root of x to the 4th is x squared. So therefore, we've got our answer. All right, now for this next one, I actually want to look at it both ways with you and kind of show you that they're both going to work, but one is definitely easier than the other sometimes. So for this one, we have both an exponent other than 1, and we have an index. So we know that this is going to be the exponent, and this is going to be the index on the radical. Our base is going to be 16. So we're going to have inside of the radical, we're going to do this 2 ways. We can do inside of the radical, we're going to have a 4th root, and then inside of the radical would be 16. Then I can raise that whole thing to the 3rd power, or I can do it the other way. I'm still going to have a 4th root, but inside I'm going to have 16 raised to the 3rd power. Either way, 3 is the exponent, 4 is the index, and they are the same thing. But you're going to see that one way is definitely easier than the other. We know that based on order of operations, we have to start from the inside and work out. So on the inside, we have the 4th root of 16. So remember, a 4th root is going to mean what to the 4th power gives me 16. So remember, I need 4 of the exact same things multiplied together to give me 16. And that's going to be 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So inside of this parentheses that's being cubed, the 4th root of 16 is simply 2. And then 2 cubed is 8. So our answer is 8. That's fairly easy. The second option, that's going to take a little bit more work. So we still have to work from the inside out. So we're going to keep our 4th root, but we're going to raise 16 to the 3rd power, and that gets really big really fast. So if you put into your calculator 16 to the 3rd power, you're going to get 4096. Well, then we have to take the 4th root of that big number, which means what times itself, times itself, times itself again. So 4 of the exact same things multiply to give you 4096. And that is going to be, believe it or not, 8. And you can always try it. Put in your calculator 8 to the 4th power, or 8 times 8 times 8 times 8, and you're going to get 4096. So you get 8 either way, but I would definitely say that this way was easier. Now that may not always be the case, but most often I think that that way is usually easier. Alrighty, so either way we get 8. You guys do which one seems easiest to you. Now let's take a look at some problems that have negative exponents. All right, so number 6. We have x to the negative 1/4 power. Well, our base is x, and we have a power of negative 1/4. So think back to chapter 5 with our exponent rules. We learned that negative exponents mean we need to flip it to the other part of the fraction. Well, currently, this is technically over 1, but we can't leave that negative exponent in the top, so we have to flip it to the bottom. So when we flip this entire thing to the bottom, then our fraction becomes 1 over x to the positive 1/4. Because if this moves to the bottom, there's nothing left other than the understood 1 on the top. When you flip that whole thing to the bottom, everything stays the same except the sign on the exponent changes. So this is really all you can do. I don't want you to write that as 1 over the 4th root of x because I can't simplify it anyway. So we're going to leave it as 1 over x to the 1/4 power. Now number 7 is basically the same thing, but this time I've got that negative exponent in the bottom, which means I need to flip it to the top. So if I still have my fraction, but this thing moves up to the top and becomes a positive 1/4 exponent, then the only thing left on the bottom is 1. And in that case, the 1 isn't really needed, so it's just going to be x to the 1/4 power. So be very careful with what we talked about in chapter 5. When you have the 1 on top, you must have it. It's important. When you have the 1 on the bottom, not needed. You can just write it like this. Alrighty. Few more to go. All right, now we're going to multiply together two things that have fraction exponents or rational exponents. We notice that they both have the same base. They both have a base of d, which means that when we multiply, I'm still going to have a base of d. But when I multiply two things with exponents, I need to remember what I do with those exponents, and I need to add them. So I'm going to take my first exponent, which is 3 over 5, and then I need to add the other exponent, which is 6 over 5. Now, luckily, these both have the same denominator, so this makes our job very easy. So we still have our base of d, and if I add my fractions together, 3/5 plus 6/5 is going to be 9/5. And then that, again, is all we can do, because even if I rewrote this thing, I wouldn't be able to simplify it. Therefore, we're just going to leave it as d to the 9/5 power. All right, number 9, very similar. So we have two things being multiplied together that both have a base of x. So our answer will have a base of x. Since we're multiplying those two things together, we're going to add the exponents. But this time, one of the exponents is negative. I don't actually want you to flip this and move it to the bottom. We're going to combine our exponents, and then if it's still negative, we'll flip it. But we're going to wait and see how it comes out. So we're multiplying two things together that have an exponent of negative 1/2 and 3/2. So we need to add those exponents together. So we still have our base of x, but when I add negative 1/2 plus positive 3/2, that gives me a positive 2/2. And then, hey, that's a fraction I can simplify. And remember, anytime we can simplify a fraction, we must do so. So 2 over 2 is really just 1, so that's x to the first power, and x to the first power is just x. So all of that simplifies to just be a plain old x. So add your exponents and then simplify the fraction if you can. So back on number 8, 9 over 5 wouldn't simplify, which is why we left it the way it came out. Alrighty, just a couple more problems and we are done for the day. Number 10. So we have the same base. They both have a base of y, but this time we're dividing them, therefore we need to subtract their exponents. Now, one thing I noticed, though, is that those exponents do not have the same denominator. And we know that if we're going to subtract exponents, they have to have the same denominator. So let's take care of that first. Since this one has a denominator of 16, we want to make this one have a denominator of 16. Therefore, we need to multiply this by 2. Well, if we multiply the bottom by 2, then we have to multiply the top by 2 as well. So then this is really y to the 2 over 16 power divided by y to the 1 over 16 power. And now we can go ahead and set it up. So since they have the same base, we keep that base as y, but we're going to subtract our exponents. So since the higher exponent is on the top, then we're actually going to subtract it, or the bottom one, from the top one. So if we take this and subtract, then that gives us y to the 1 over 16 power, because 2 minus 1 is 1, and the denominator stays the same. Therefore, we have y to the 1/16 power. And that's it on that one. Now for number 11, we have a little bit more work to do. So we see that we do have a base of x for both the numerator and the denominator. However, I'm not ready to just start subtracting exponents because on the top, I have to do a little bit with that first. So I need to simplify the numerator before I can start subtracting exponents. Now, I have x to the 3rd power raised to the 1/2 power, which means I need to multiply these two exponents together. Now, when I multiply, I need to remember that this is technically 3 over 1. So when I multiply those exponents together, because it's a power to a power, I multiply. I'm going to have x to the, well, on top we have 3 times 1, which is 3. On the bottom we have 1 times 2, which is 2. So the top, simplified, is just x to the 3/2 power. Then in the denominator, we have x to the 9/2 power. Well, we know because we have the same base that we can subtract these exponents since it's division. Now I know that the denominator has a bigger exponent, therefore I want to actually move this one down and subtract it from the other one. So this gives me 1, because remember that's gone, so all that's left is that 1 on the top, and then x to the, well, 9 over 2 minus 3 over 2 is 6 over 2, because 9 minus 3 is 6, keep the denominator the same, and then that fraction can simplify. So I still have 1 on the top, but then I have x to the 3rd power, 6 divided by 2 is 3, and then that's really all I can do. So your answer is 1 over x to the 3rd power. All right, so that is all we have for today. And then you guys will want to get your assignment done. And then I believe that you also have a quiz coming up. So keep an eye on that and watch your due dates. And I will